Okay, let's do Unit 4, Section 2. This time we're going to do power to a power. So here's the thing. Each of these rules in and of themselves aren't overly complicated, but when we start adding rules on top of rules, if you haven't practiced the first rule and you're adding another rule on, they can get confusing. So you really need to practice these, okay? So I know you don't like to do the homework, but do each one, at least get some practice in so that when I add another rule, you have the other one solidified in your mind, okay? So we're going to do the same thing. An example, expanded form. Then we're going to expand it even more. And then we're going to come up with a simplified solution, okay? So it's kind of what we did before, but we need to come up for a different rule this time, okay? So for example, if we have 2 to the 3rd power and then parentheses raised to the 4th power, let's think what that means. Let's start with this 4. That means we have 2/3, 2 to the 3rd power written 4 times. So that's going to be 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. Now if we want to be even more difficult, we can expand each of those. So that's 2 times 2 times 2, 2 times 2 times 2, 2 times 2 times 2, 2 times 2 times 2. How many 2's altogether are we multiplying? We're doing 2 to the 12th. And that's going to equal, if you put in your calculator, 4,096. Okay? Now you can see why mathematicians came up with a shortcut. They don't want to write it out every time. So let's look at another one. And hopefully you're thinking of what the shortcut could be so that you don't have to write this table out every time. This is a lot of writing. X squared to the 3rd. Again, we're going to look at this one on the outside. That means we have 3 x squares multiplied together. And then we're going to expand each of those. So we have x times x, x times x, x times x, and that's going to be x to the 6th. So hopefully you're starting to see the pattern here, because nobody wants to sit and write this out every time. But I just want to make sure we have the concept, the idea behind the rule, and why mathematicians came up with it. Y to the 5th raised to the 2nd. So this time we have y to the 5th times y to the 5th. So that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How many is that all together? Y to the 10th. Now here's the tricky ones. When a number is involved, you have to be careful. And I'm going to do the same thing that I did when we were multiplying like bases. So we have parentheses, 2. And you can't forget the old rules. The old rules still apply. We're just adding new ones. 2 to the x to the 3rd. I don't even like to call them rules. They're more like shortcuts. Mathematicians are all about what's the pattern we see and how can we make a shortcut so we don't have to write it out every time. So we have 3 groups of 2x to the 3rd y squared because of this 3 on the outside here. Okay? So that we're going to write that 3 times. Whoops, sorry. And now I'm going to group it like I did before. Okay, so I'm going to group my 2's. 2 times 2 times 2. Then I'm going to group my x's. X times x times x, x times x times x, x times x times x. And then my y's. Y times y, y times y, y times y. Okay, now this is where people have to be careful. It is still 2 times 2 times 2. That is not 6. That is 8. Because 2 times 2 is 4. Times 2 is 8. Now how many x's do we have? We have 9 of them. And how many y's do we have? 6. So of course mathematicians said, I see a pattern. I'm not going to write this out every time. So here's the shortcut, or like we call them, the rule. The rule is, if you have a power to a power, now this only applies exponent to exponent. This doesn't apply to the coefficient or the number out front, like this 2 out here. This is still 2 to the 3rd power, so it's still 2 times 2 times 2. A power to a power, you multiply, whoops, let's go back to the blue, that's going to bother me. You multiply the exponents. Only multiply the exponents, and you can see why from this 4th example up here, okay? All right, so let's just, for those of you who have it, go ahead and go do your homework. For those of you who would like one or two more explanations, here I'll do one or two more. So number one is y to the fifth squared. So it's a power to a power. So we multiply 5 times 2 is 10. Okay, that's the shortcut for all this work that we did up here. That's what mathematicians like. They like the patterns and then the shortcuts. Now watch this one, negative 3 parenthesis, b to the fourth to the all to the third. Now you have to be careful here. First of all, we have a 1 on this a. This 3 is outside of the exponent, so nothing happens to that 3. It's outside the parentheses. And now we're going to multiply exponents. A to the first times 3 is a to the third. We're multiplying. B to the fourth to the third is b to the 12th. Okay? Let's try another more complicated one. Number 3. Now this time I'm going to put the number in the parentheses, and that's going to change things. Okay? So what this really means is negative 2 squared, a to the fourth squared, b squared squared. And this is where you got to be careful. Just so you know, this means negative 2 times negative 2. What's a negative times a negative? It's a positive, so this should be positive 4. Now if you put that in your calculator without the exponent, and I'm going to say this over and without the parentheses, you're going to get negative 4, which is the wrong answer. Your calculator isn't wrong, you just aren't using your calculator correctly, and I'm going to hit that a lot. I'm going to talk about that a lot. Now this one is a to the fourth to the second, so we multiply. Because it's a power to a power, it's a to the eighth. And the last one is 2 times 2, so that's to the fourth. Let's do one more complicated one. Number 4 is 4a squared, b, that whole thing raised to the third, and then we have 2b squared raised to the fifth. So there's a couple ways you could shorten this. Some of you may not need to shorten it, but really what we have is 4 to the third, a squared to the third, b to the third, times 2 to the fifth, and b squared to the fifth. So let's simplify that down. Okay, 4 to the third is 64, because I did this ahead of time. A squared raised to the third, power to a power, multiply. B to the first to the third is 1 times 3, so that's b to the third. 2 to the fifth is 2 times 2 times 2 times 2 times 2, which is 32. And then we have b squared to the fifth, again, power to a power. Now this is where you have to realize, now we're going to go back to lesson 1. Now we have like bases. So I'm going to regroup 64 times 32. A to the sixth, there's no other a's. B to the third times b to the 10th. Now we're multiplying like bases. We're not doing power to a power. So this is going back to the rule from the other day. Well, first I multiplied these and I got 2048. Thank you, calculator. A to the 6th doesn't have anything to go with it, but b to the 3rd and b to the 10th, like bases, add exponents. So that's b to the 13th. Okay, that's your final answer.